Hello everybody. In this tutorial I want to show you how we can calculate the confidence interval for some continuous data. So here's our question. You measure the blood concentration of a metabolite in 5, so that's our number, sample number, 5 healthy volunteers, and get the following data, and everything is measured in micromolar. So here we have our 5 observations. 1, 2, 3, 4, 5. So it's always a good idea to double check, and the data look like they are continuous data, so they are not just count data or proportions or something like that. They are continuous data. And the question is now, how can we determine the, say, 95% confidence interval of the population mean? And we've discussed in previous videos what this actually means. We want to really see where we believe is the true population mean from this particular sample. And in order to do so, to get this confidence interval, we need to perform a few steps. It looks worse than it is, and we can let Excel do most of the heavy lifting. So the first question is the count. That's our sample size, and we've got that given. That is 5. That is our sample size. The next question that we have to answer is the degrees of freedom. And the degrees of freedom actually is the number of observations that we need if we have already some information about the sample. So that would be, in this case, 5 take away 1. So here the degrees of freedom would be 4. The next thing that we want to find out is the mean of our measurements. What is the average of the measurements? Because we will say that this average of our measurements will also be our best estimate for the population mean. And we can do that with Excel. So we start an equation equals, and then we start typing average, which is mean. Double click on it, left mouse button pressed, and we highlight the cells that we want to calculate for the average. Close the bracket, and we get an average of 31.1 micromolar. In the next question, we need to find out the standard deviation of the, in this one here, we need to estimate the standard deviation of the population. Now we don't know the standard deviation, we don't know the variability of the population. All we have is the variability and the standard deviation of our measurements. But we can make an estimate for the standard deviation of the population. So here we start with equals stdev, and you see we've got two different ones. This standard def S that we are going to choose here is the estimate of the standard deviation of the population when we are dealing actually with a sample. So that would be the right one. So let's double click that, and again we highlight the cells that we need and close the bracket, and we get our estimated standard deviation of the population. The next step is we need to find out the standard deviation of the sampling distribution for the mean. And we have said previously that this would be the standard deviation for the sample mean, that's for the sampling distribution. And we can estimate that as the standard deviation that we just calculated divided by the square root of the number of observations that we have. So that would be the equation that we have to put in here. So this would be the standard deviation, our estimate for the standard deviation of the population, that is this one here, divided by the square root, and this is this SQRT, and this is the observation number, and here we have 5, close the bracket. So this is our standard error of the mean, which is very often called. Next step is we need to calculate the significance level alpha. That's also our type 1 error that we are, so type 1 error in this case, that we are willing to accept. And the type 1 error, that's very easy to calculate. The alpha in this case would be 1 minus the confidence interval number that we have, and that is this one here. So that's 95%. We want to be 95% sure, so we are willing to make a 1 minus 0.95% error. So we can calculate that. Equals 1 minus 0.95, and we get an alpha of 0.05 or 5% alpha. Now we also need to calculate then the margin of error. So we calculate the margin of error, and the margin of error is the critical t-value times the standard error of the mean, which is exactly this value here, what we have calculated. So in order to calculate the margin of error, we also need the critical t-value. And in Excel, you can calculate the critical t-value. This critical t-value depends on the standard, on the significance level. It depends on alpha, and it also depends on the degrees of freedom. So that is what this depends on. So we can calculate that equals t dot, and this is the function inf 2t. So that's this function here. T inf dot 2t. The 2t stands for two tails. Now we need the probability, and here the probability is the probability of making a type 1 error. So that is this one here. And we need our degrees of freedom. That is this one here. So we get a critical t-value here of 2.7 rounded 8. And now we can calculate the margin of error. So what we need to do is we multiply this critical t-value with the standard error of the mean that we've calculated here, and we get a margin of error. So we can say, actually, we believe that our population mean, which we have calculated here, or we've estimated here, so the population mean would be 31.1 micromolar plus minus the margin of error, which is 14 point. Now we need to be careful with the decimal numbers or decimal places. Here we've got only one decimal place, therefore it is apt to round this margin of error also to one decimal place, so to 14.7 micromolar. So what we are basically saying is that in this interval that is defined by this sort of range, in this interval we are pretty sure that our true population mean is if we took loads and loads of samples with these volunteers. We now can calculate the upper and lower bound. So all we need to do is we just simply add to the population mean the margin of error. Then we get the upper limit, so equals margin of error that we've calculated here, equals like this, equals this number. No, it won't let me. So equals 31.1 plus our margin of error, and we calculate the lower bound, so that would be 31.1 minus the margin of error, and we get 16.4. So what we are basically saying is that we believe that the true population mean is somewhere between 16.4, and again I round, and 45.8 micromolar. We are pretty sure that the true population mean is located somewhere in there, and this estimate for this confidence interval is derived from this particular sample here. Now, if we had a different sample, we would come up with a different estimate for the true population mean, but by definition we calculate this population mean in such a way that 95% of our samples that we could take, and we can take gazillions of samples, that 95% of our samples would actually contain the correct true population mean, which we, however, will never know what it is. So I hope this makes sense, and it shows you how we can actually calculate the confidence interval. Now this is a fairly long-winded way of doing, because Excel luckily has another function for that, and we can do that much quicker. We can calculate this margin of error with a little sort of a little trick, and for that is you use the function equals confidence t, and we are looking for this one here, confidence t, and it asks us about the alpha, that is our type 1 error, alpha. It asks us about the standard deviation, the estimated standard deviation, that's this one here, and it asks about the size of our sample, that's this one here. Close the bracket, and if everything goes well, we should get our margin of error 14.65. So with this little trick, you don't have to go through all these calculations. You immediately get the margin of error with the confidence t function. So I hope this is useful for you, and thank you very much for watching.